Yeah. Yes. Can you put on the switch also? That switch. Okay. So let's start the session. So in the discussing about the regression. Honest students, can you please confirm if my voice is loud and clear? It is stable now. It is clear. Yes. So just give me a minute. Okay. So let's start. Right? Where what is meant by regression project means project is we have to create a model. We have to create a model. Create a model which can which can predict which can predict minimum error, which can predict the output with minimum error. We have to create a model which can predict the output with minimum error, right? This is general any ML or any ML, not only regression, any ML. Now coming to the particularly in the regression, the only difference is we have to create a model which can predict the same to same predict the continuous variable, the output which is continuous, the output, whatever the output is there, the output which is continuous. The word we have to add, the output which is continuous with minimum error. The any ML algorithm, we have to create a model which can predict the output with minimum error for anything, whether it is a classification, clustering, regression, whatever it is, whatever the ML and whatever the AI algorithms we are going to design. For all the ML and AI, the concept will remain with a create a model which can predict the output with minimum error. This is common for everything. Particularly within the regression, the output variable is continuous. That is the only difference where we are having the output which is continuous, right? Now here the regression. So now we are in the regression. Whatever the regression we are having, the regression we are having in the regression multiple algorithms. Within the regression, we are having the multiple algorithms. Within the regression, we are having multiple algorithms. So what are the different algorithms we are having within the regression? Means first we are starting in today's class linear regression. Within that, first one is linear regression. Within the regression, this is the first one. Where linear regression is assuming the data is linear and identifying the relation as linear equation, which is nothing but y hat is equal to beta 1 x plus beta naught. Now, assume now what is linear regression? If someone asks you what is linear regression, heading as linear regression. Heading is linear regression. If someone asks you what is linear regression is nothing but assuming the data is linear, assuming the relation between input and output, assuming the relation between input and output is linear, and trying to build a linear model between them, trying to build a linear model between them by assuming the data is by assuming the relation between input and output is linear and trying to build a linear model between them, right? Now, already we have discussed we are having two. One is linear regression. The second one is multiple regression, right? Just give me a minute, guys. Your voice is breaking. Voice is not clear. Guys, can you please confirm now? I have changed the Wi-Fi. Can you please confirm me now? Now internet is stable. Okay. Yes. Now it is clear, right? Done. So linear regression. What is linear regression is? The linear regression is assuming the relation between the input and output is linear, and we are going to try to build a linear model between them. Now, what is meant by linear model? Okay. So still Balreddy is saying that voice is not clear. Guys, others? It is clear, right? For everyone, it is clear, right? Okay. Yeah. Now it is stable. Earlier it is unstable, but now it is stable. Done. So if it is not clear, can you please re-log in once again? Right. So linear regression, assuming the relation between the input and output is linear, and we are going to try to build the linear model between them. In this, we are having two. Now here, build the linear model between them. Linear model between them. What is the linear model between them is, this is the one which we are going to understand now. In the simple linear regression and multiple linear regression. Simple linear regression means we are having one input variable, one input variable, one output variable, one input variable and one output variable. Then in that case, we are going to apply the simple linear regression, and we are going to try to build the model. The model is y hat is equal to beta 1x plus beta naught. Okay, this is the equation. Now in the multiple linear regression, we are having more than one input variable, more than one input variable. If you are having more than one input variables, output will be one only. Output variable will be one. If you are having more than one input variables and along with that one output variable, then in this case, we are going to apply the multiple linear regression. The model will be in terms of y hat is equal to beta 1 x1 plus beta 2 x2 plus beta 3 x3 and so on, plus so on up to beta n xn and plus beta naught, common beta naught. Beta naught is common. So the equation, whatever the equation we are having for the multiple linear regression is y hat is equal to beta 1 x1 for x1 beta 1 plus beta 2 x2 plus beta 3 x3 so on up to beta n xn plus beta naught, where n is the number of variables. If 10 variables are there, means beta 10 x10. 20 variables are there, means beta 20 x20. Till that, beta naught is common, right? Now, sir, how to calculate here the beta 1 and beta naught? How to calculate these two values? As we know that beta 1 is calculated based on the sigma x minus x bar into y minus y bar divided by sigma of x minus x bar whole square. And beta naught is calculated by y bar minus beta 1 x bar. This we have already seen. Now here also same. Beta 1 is calculated based on the sigma of x1 minus x1 bar. For the first variable you have to take into y minus y bar divided by sigma of x1 minus x1 bar whole square for the first variable. Now second variable beta 2. x2 minus x2 bar into y minus y bar divided by sigma of x2 minus x2 bar whole square. Instead of considering here 1, here you have to consider the multiple. For you are having here only one x and one y. So for that you are having the only one x bar, single x bar only is available. Here you are having multiple. So you are having multiple x1, x2 and y. So now since we are having 3 of them, now x1 bar is separate, x2 bar is separate. That's it. Okay, you are having x1 bar separately, x2 bar separately. X1 bar you are considering with y, and similarly x2 bar you are considering with y. Similarly, how you have worked here with x with y, here x1 with y and x2 also with y. Separately we are going to do. Is that clear? Now, so this is with respect to called as multiple linear regression. Now, in the both the examples, whether it is a simple linear regression or whether it is a multiple linear regression, the ultimate concept of both of them is our requirement is sigma y minus y hat whole square should be minimum. This should be minimum. Where y, in this case, the y hat equation is only one variable. In this case, the y hat is consisting of multiple variables. But ultimate is y minus y hat whole square should be minimum. The sum of the squares of error should be minimum. SSC should be minimum. If SSC is minimum, then it indicates that MSC also minimum. If MSC is minimum, it indicates that RMSC also minimum. Our ultimate goal is RMSC should be minimum. The error should be minimum. Right? So here, whether it is one equation that is one input variable and one output variable, or multiple input variables and multiple output variables, the concept is remains same. The error should be minimum. Okay. So let us see the project. Let's start with the first project. Now, in the notes, we have to write the steps involved. Steps involved in data science project. Steps involved in the data science project for a data scientist. Okay, steps involved in data for data scientist means apart from data scientist,